Hello and welcome to this tphysics Christmas programming tutorial. In today's tutorial we're going to be looking at how to use tphysics to create a snow globe. So we're going to start out by searching GitHub tphysics. We could also search the Billington tphysics and you should find this link here. Now this is going to open up GitHub, and the thing we're interested in this repository is tphysics.py. So we're going to go into here and we're going to click on copy raw file, or alternatively we can open the file as a raw file and we can copy all the code from in here. But I'm going to just click on copy raw file, and now we're going to want to put that Python file into our idle. Okay, so I'm going to go into idle, I'm going to create a new file, I'm going to paste all of that code like that, and then we're going to save it. Now when I save it, I'm going to put it in whichever folder you normally save your code in. So for me, I'm going to save it in examples, and we're going to call it tphysics.py, and it needs to be called tphysics because we're going to be importing from this file. So we're going to call it tphysics.py, and then we can forget about this. Okay, so we're going to create another new file, and we're going to again save this file. We're going to put it in the same folder as where we put our tphysics.py file. If we don't put it in the same folder, this won't work because we're going to use this to import our tphysics code. Okay, so we're going to call this one snowglobe.py, and then the first thing we're going to do is we're just going to get a basic tphysics window set up. So we're going to say from tphysics import everything, and we're going to create a brand new game window. I'm going to give it a name, Snow Globe. You can call it whatever you want. I'm going to give it a color dark blue, and we're going to make sure that it's set to full screen, with full screen equals true. Then we're going to create a infinite while loop, a while true loop. This is called a game loop. This is where all of our code to control our snowflakes is going to go. But for now, we're just going to say game.update. That means every time that this loop runs, it's going to update the game. So if we run this code with F5, you can see I have a new tphysics window, a turtle window called Snow Globe, and it's got a dark blue background. The next thing we're going to do is we're going to just create a snowflake. So we're going to say snowflake equals a new circle. We're going to just put it in the middle of the screen for now. We're going to give it a radius of 20, and we're going to give it a color of white. And you'll see when I run this now that nothing has actually happened yet because we need to add it to the game. So we use the add shape function to add our snowflake to the tphysics window, and now when we run it, you should see we've got a white snowflake in the middle of the screen. Now you can see that it has got a black outline. We can either leave that there or we can set its line color. So we can say snowflake dot line color equals white, and that should hopefully make it fully white. There we go. You can see a little bit of blue creeping through there. But yeah, so we can make that white. We can also disable the line color entirely. I can't remember off the top of my head how to do that, so let's just double check quickly. If I go to color in our readme, we should be able to see if I do dot line. So if we say snowflake.line equals false, we should be able to stop that from going, from showing. So if we say snowflake.line equals false, and we run it again, you should see we've just got a nice white snowflake. Now I can still see a little bit of blue through there. I'm not sure why that is, but either way, that's how we can control our line color, our fill color individually. And yeah, so let's just go with a white snowflake for now with a bit of a black outline to it, and we're going to need to get it to move. So in order for us to get this snowflake to move, what we're going to want to do is, well, basically we're just going to get it to move every single frame. So we're going to say snowflake.y minus equals 1. And what that's going to do is every single time this loop runs, we're going to take 1 from the y position, which remember that's the vertical position of the snowflake, and then we're going to update. We're going to draw a new frame, and then we're going to do it again. So every time that this runs, we should see our snowflake is now falling. But actually, we don't necessarily want all of our snowflakes. We don't want just one snowflake. We want lots of snowflakes. So instead of having this snowflake here, we're going to actually turn snowflakes into a list like this. So we can say snowflakes is a list of these, and we're going to, instead of just having one circle, I can create as many as I want. So I'm going to say for I in range 100, So we're going to do this 100 times. We're going to say snowflake equals a new circle, and we're going to add it to the game, and we're also going to add it to the list of snowflakes. So we're going to say this list of snowflakes here, we're going to append a brand new snowflake into there. And actually, it's not going to be very fun this if all of our snowflakes are in the same position and they also have the same size. So we're also going to import our random integer function. Now, our random integer function basically does what it says in the tin. It allows us to generate a random integer between the values of the first number and the second number. Now, because we're using this full screen, we're actually going to need to know the screen size. So we're going to grab screen width and screen height, and we're going to get it from our game.getWindowSize function, and this should hopefully be able to tell us our screen width and our screen height. So we're just going to check what those two values are. So let's run that again. And there we go. We can see our first snowflake is falling. We've generated obviously a lot of snowflakes. They're not falling yet because we're only updating one snowflake. And we can see that we have our screen width and screen height here, which is really helpful because now when we generate all of our snowflakes, we can make sure that they're all off the top of the screen. And the way we're going to do that is by getting half of the screen width and half of the screen height. So let's say we want to generate, this is going to be a little bit complicated, but just bear with me for a second. So the first thing we're going to want to do is generate a random position on the X. So that can go from minus screen width over 2 to screen width over 2, because 0 is the middle of the screen. So if the screen width is 1920, then we can go from minus 960 to 960. Okay, so we're going to say that our X position is going to be a random integer between minus, and remember we want to cast this to an integer because we're going to be doing a division. So we're going to say screen width over 2. So we're going to get it between the left hand side and the right hand side of the screen. Okay, so we're going to get a random integer. Now it's going to be a little bit simpler for our Y because we always want it to be off the top of the screen. So we're going to say our Y is going to be a random integer from, in fact, we're going to start at the top of the screen. So we're going to say screen height over 2. We're going to cast that to an integer, and then we're going to add a random amount onto it, and it's going to be a random integer between, let's say, 30 and 300, or 30 and 50. And what that's going to do is it's going to allow all of our snowflakes to generate, in fact, let's make it a bit bigger, let's make a bit more variance. It's going to allow all our snowflakes to generate off the top of the screen. In fact, let's make it even bigger in its variance. Let's put it up to 300. I'm not sure how good this is going to look. Now, the other thing we're going to want to do is we're going to want to grab some speeds. Now, these are just going to be, again, random numbers. And our speeds can be anywhere from, let's say, 2 to 7. So speeds dot append a random integer between 2 and 7. And this is going to allow each snowflake to fall at a different random speed. And then the last thing we're going to want to do is also generate a size. So we're going to say size equals random integer between, let's say, 5 and 30 radius. I don't know how big that's going to look, but we can play with these numbers in a minute. And now we're going to want to replace our X with our randomly generated X value, our Y with our randomly generated Y value, and our size with our size value. And that should hopefully, if we get rid of this just temporarily, this screen height, we should hopefully now have a load of snowflakes all over the screen. That looks really good. So the reason that I got rid of that then was just because this takes those all off the screen. So if we run it again, you'll see that they'll all start off the screen, and then in a second, if we wait, we would see a snowflake fall onto the screen. Now the next thing we need to do is not just move the one snowflake, but we need to move them all. So we're going to say for snowflake in snowflakes, actually no, we're going to do I in range because we're also going to need to check their speeds, which means we're going to need an index accessor. So we're going to say for I in range, and we're going to go up to the length of snowflakes. So that says for I equals 0 up to the top length of the number of snowflakes. So we're going to have I equals 0, 1, 2, 3, all the way up to, well, currently we've got 100 snowflakes, but we might increase that in a minute. So for I in range to the length of the snowflakes, we want to take snowflakes I, we want its Y position, and we want to take away its speed. And that should make all of our snowflakes fall at a different speed. And I think that should give us a bit of a snow globe effect. Fantastic. Now, I'm not so keen on the top size of these, so we're going to make them a little bit smaller. So the maximum size that we can now have is going to be a radius of 20. And let's also add another 100 snowflakes in as well. And now, there we go. And you can see it looks like it's slowing down a little bit. And of course it's going to slow down a little bit because it's got lots of snowflakes all falling. So let's increase this range a little bit as well, just to space them out a bit more. And then the last thing we're going to need to do is we're just going to need to check, after we've done this, if the snowflakes Y position is less than, and we're going to need minus half of the screen height, like that. And actually we're going to also take away the radius of the snowflake, because think about it, if we just check the Y position, then when it gets to the bottom of the screen you'd still see half of the snowflake and it'd suddenly disappear, whereas this way we're making sure it's fully off of the screen because we draw the circle from the middle. So what we're going to do is, if we see that, then we're going to just regenerate its Y position. Now if we run that, we've got a really nice snow globe effect. I'm hoping. We probably need to regenerate the speeds as well, actually, and maybe we should want to slow them down a little bit. So let's do this, and we're going to say speeds I is going to be another random integer like this. So we're going to say speeds I equals another random integer. So that's going to randomize the speed each time as well. So we start. We've got all of our snowflakes. They're falling down. We should hopefully begin to see that they start falling from the top again. So when they fall off the bottom here, we're regenerating them. And we might also want to give them a new random radius. So we're going to do a random radius again, and we're going to say snowflakes I dot radius equals a new one there. And we're also, let's just for completeness, we're going to completely regenerate each of our snowflakes whenever they go off the screen. I'm going to say generate a new X position as well. So this should completely randomize every snowflake. So whenever they go off the bottom of the screen, we're going to be generating a brand new position for them. And hopefully over time it's going to look like they space out a little bit more as well. Get a bit more randomization in there. So yeah, there we have it. Thank you very much for joining this Christmas tphysics tutorial. I hope you found it interesting. I know that it was a relatively complex idea to share, but I hope that you found it useful. And I'll be sharing more and more tphysics tutorials into the new year.